Good morning, everybody. Mike here from Southern California. We've been getting a lot of questions lately about how to transition from block-based languages to text-based languages like Python, and how to do that while also hitting a math standard can be a little tricky, but we think we have the answers for you. So let me just transition here over. We're going to use a lesson today called The Legend of the Chessboard. It's a really nice story that illustrates the power of exponential growth. And I recommend searching that. If you search Legend of the Chessboard, you'll find these quick videos, 2-minute video, and I recommend watching those with your kids. And obviously you previewing them first. When you go to our site, this will be downloaded if you go to csmmath.org. This will be loaded into lessons in secondary after this video. And what you'll find in there are 2 lessons. One is the teacher outline. So the first one that comes up will be this teacher outline, and it shows those math standards that we're hitting. Notice those are 8th grade standards. And I'll also show like what commands are we going to use. So today we're just focusing on basic variables, basic looping, and printing. If you know nothing about Python, you can watch some of these videos we have linked on operations of variables, loops, functions, or what's called concatenation. And then the student handout link, which you click here, is what you'd actually pass out to students for them to go through. All right, now in terms of where to write the lesson, I recommend using Trinket. If you search Trinket Python 3, pull that up. Notice it recognizes me, but you'll have to create an account and log in. I'm going to click on My Trinkets, and notice the Legend of the Chessboard lesson. Everything that I've done so far is saved in there. If I want a new one, I just click New Trinket, Python 3, and that pops up. So I'd recommend that you get set up on there, pause if you have to. And I'm just going to make this font just a little bit bigger. If you don't like Trinket and don't want to use it, the second option is REPL.it. Again, it's just a nice way to add in an online version of text-based coding. So those are the 2 that I like. If you have something that's downloaded and the kids have laptops, then obviously you could use something else. Okay, hopefully you're here and set up, and we're going to start writing programs. So the first thing that we're going to do is just title each section. So in Python, the hashtag actually won't run in your code. It's like a commenting indicator. So if you put a hashtag and then type I'm going to put initializing variables. So the first thing we're going to want to do in our program is initialize a variable. And in sequences, we just start with a value. So you can title it any variable you want, but let's just say we're going to call the variable value, and we're going to set value equal to well, on the lesson, maybe we'll just kind of walk through some of them in the lesson. The one I have, well, you'll be having kids walk through is make 3, 5, 7, 9, 11, that addition sequence. So we started at 3. So maybe on that one, we'll start the value at 3. And if there's other variables, you can just initialize or start them all in that top area. And then we're going to do our operations with it. So for this lesson, we're going to use loops. Usually you do for I in range, like range meaning how many times do you want to loop it. So maybe I'd just start with something easy like 3, and then I would end that with a colon. Hit enter. Notice how it's indented, 1 full space. That's important. Everything inside a loop needs to be indented. And instead of I, I'm going to use n. So in math, a lot of times we use n for the number, for the placeholder. And so all we're going to do is say take the value and make that value equal to value plus 2. Because in our sequence here we're saying go from 3, add 2 to it, then add 2 to it again, then add 2 to it again, and so on. So in the code here, what you'd see is we're going to set the initial value to 3, and then 3 times we're going to loop it through and say add 2 to it, add 2 to it, and add 2 to it. Okay, now nothing will happen if I run this. If we run this at the moment, it's going to say running, but nothing happens because we haven't printed anything. So to make things show up, you have to have some kind of displaying mechanism. For Python, it's called a print. So we're going to print the value each time. Okay, so let's say we run that. Good, so notice it's it doesn't start at 3, it starts at 5, 7, and 9. And if you think about the logic of why that happened, it's because we printed after we added 2 to the original value. So one way we might get that to print the first number is to cut and paste the print statement to happen first in the loop. And if I run that now, you'll get the 3, 5, 7. So on here, we have 3, 5, 7, 9, 11. If I wanted 2 more numbers, I would just loop through 2 more times. So then I would change the looping to 5, and I would click Run. So I challenge you, once you have this and have a reasonable understanding why it's working, to pause the video and try to get this second sequence generated. So I'm going to pause the video now. Okay, so sorry I lost something there, but hopefully what you did was you went and you changed the initial value to 8, right? So for this sequence here, the initial value is 8, then you're constantly adding 3. So in terms of modifying the code, the initial value is 8, and you're constantly adding the 3 here. And if you print it, sorry, I've got to rerun that. If you rerun this, you get 8, 11, 14, 17, 20, just like we wanted. Now it prompts you in here to find the 50th term, right? So what would you change to get the 50th term? You just change the range to 50 or whatever you wanted to loop. Okay, so that is the basics of it. We should have probably commented out the second part. It's good for kids to get in the habit of writing comments, so if other people are trying to read their code, they know what's going on. So this is like looping through the operation, or whatever you wanted to call it, right? But you're looping through the addition operation for arithmetic sequences here. Now, if you connect this to Legend of the Chessboard, this is, well, you know what I should have added here is if I was doing this same code in Scratch, so if you've done block-based coding before, I do have that drawn up here in Scratch. So if you watch, if I click the green flag, it's going to set the initial value to 8, and this repeat 5 times is the same thing as this for loop. So it's actually really good to connect this for kids, like show them the connection between the two. There's not a print block, but there's a say block, right? So this print block is the same thing as a say block, or sorry, that say block is the same thing as a print block, and we're setting the value to value plus 3, the same thing we did on the Python code. So if I run this, notice how it rolls through the values and prints them for 0.2 seconds each. So those are equivalent programs. What you get with block-based coding and why it's a little bit more advantageous is because there's no errors. Whatever you have in here will run and will work. Now if you go back to Python and let's say you delete out this colon and run this, it'll give you an error message. But it's really good for troubleshooting for kids to look at it and say, well, what's gone wrong here? Notice how it gives you a line number. It says in line 6 you've got an error. And it says invalid syntax, and it's even got a little arrow saying on Trinket, that's where your error is. Let's say it was somewhere else, like maybe I was typing, and instead of putting value, I missed the E. And if I try to run this, again, it's going to say there's an error, there's something wrong. It is going to tell you the line again. So at line 8, it says value is not defined. So again, this is just a good troubleshooting thing for kids to run into and to think about what they need to do to fix their code. So in Scratch you don't get this, in text-based coding, right, you get this, whether it's Python or Java or whatever. Now to end with in the video, let's transition over to, again, to the Legend of the Chessboard, which is more based on multiplication. So instead of looking at it, right, the concept was that you're going to start with 1 grain of rice, then multiply it by 2 or double it, then multiply it by 2 or double it, multiply it by 2 and double it. So how would we change our code? Well, we would come back here. Maybe I'll give you a chance. What would you do to change this? You can pause and try to change the code to match that Legend of the Chessboard scenario. Yeah, hopefully you initialize the value at 1, and then you said, well, you're not adding anymore, you're constantly multiplying. Now, if you didn't know the multiplication symbol, it's the asterisk, which you can get by pressing Shift 8, and then you're going to just double it. So let's run this code and see what happens. Start it at 1, to 2 to 4 to 8 to 16, which now models the legend of the chessboard concept. And we can go a lot. This is kind of low floor, high ceiling. You could go wherever you wanted to with this, but again, you could say, well, there's 64 on the chessboard. There's 64, and you have to be a little careful here, right? Because this is actually the 63rd amount. So Python, the way we have this looped is that the value here, the print value, is first. So that last multiplication of 2 we never got. So let's say I want to copy that, and I'll just not include it in the loop, but at the end we'll just print that value one more time. So let me run that. So this is actually the amount. I think there's 18 zeros there if I remember right. So this is like 18 quintillion or something crazy. And that's just in the last days. So again, what it does is it really illustrates for kids the power of the exponential growth. Or you can try moving this print value. You can even turn it off in here. Let's say I put a hashtag inside of this code. Now it won't print as it's looping through because it's that line of code is now a comment. It's turned off. So if we run that, notice it just prints that last this last print statement. So again, there's so much we could do here. I just wanted to introduce it with you, get you feeling it out. And then what I'd recommend is going to the website, it's csandmath.org. Go to the secondary, so go to lessons secondary, and it will be in here at the bottom if you wanted to finish it out. So thank you guys so much for watching, and let us know what you think of the lesson. Thanks.